Hello. I'm going to say good morning because it's morning here in Tucson. This is the second video that I said I was going to do for you. Uh, like with a lot of things we go over, and I get it, you kind of just want the homework stuff, which is helpful. But then learning how these things actually work, and sometimes the why, makes doing problems you see later on a lot easier. And again, to your point, because it's a very good point, in class, it often goes so quickly that you don't learn all these things. And so it just makes things harder. So this video is to kind of go over the little pieces, the mechanics is how we refer to them, so that doing rational expressions makes more sense. So that when you do see something different or more complicated, you're actually able to go through the steps to at least make a very good try at it. And this is actually what I use in class. So this is what we would do in class. We're not going to go over the whole thing because rational expressions is a huge topic. So it's something to get down well because it's not going away. And there are a lot of variations and different parts to it. So we're just going to go over some of the parts of it, let you absorb it and get used to it, and hopefully practice some of this. And in the next video, I will go over another example, so you can see how these pieces move, and we can go from there. So one of the things, and this is, like I said, I use this in class. So we're going to talk about simplifying rational expressions. Rational expression is just a fancy way of saying fraction. Okay, so we can express fractions in a lot of different ways. It is something that I would suggest being very good at, and we can work on that. But we can express fractions in a lot of ways. We can do it as a decimal, as a fraction, as a percent, as a ratio. And that's where the word rational expressions come from. It comes from ratio. So if we were to pronounce it to reflect it, it'd be rational expression. And that's just awkward. So we don't do that. So all a rational expression is a fraction. And to kind of go over, and this is just the fancy definition, again, fancy definitions, who needs them? We can get fancy in our fractions, okay? So anything over something else is a fraction. It's just a more complicated fraction. But let's take a second to go over what a fraction is. A fraction is just a relationship. So it's a number over another number. And all the fraction means is I'm going to divide that top number, the numerator, by the bottom number, the denominator. That's all it means. So if you were converting to decimals, that's how you convert to decimal. You just divide the top number by the bottom number. Then you get the decimal form. And so, but if you think about it, and I know every teacher in the world uses the pizza example, but the pizza example is probably one of the best examples. If you divided a whole pizza in half, out of that one pizza, you have two pieces. So 1/2. Big number on the top, or the thing that you're dividing up, how many things do I have, over how many pieces do I want that to be? Okay, so that's all a fraction, or how many pieces I have. That's all a fraction is. I have one pizza, so that's the number that goes on top. I'm splitting it into two pieces. So two perfect half pieces put together actually add up to that one whole pizza. That is what a fraction is. Now, when we get into these rational expressions, and as big and ugly as they get, it's still saying the same thing. And again, we go back to the concept of like our variables. All a variable is saying, I don't know. We're probably going to find out along the way. And we can still say it. So if we look at this 4x plus 3y over 2x squared minus 3xy plus 4y squared, this is the same thing as the pizza example. All we're saying is I have this entire 4x plus 3y, whatever that is. We don't know what it is yet. And I'm dividing it by 2x squared minus 3xy plus 4y squared. We don't know what that is either. So it's the same concept. We're trying to do the same thing as the 1/2 in the pizza example. We're just expressing it in a complicated way, and of which your job is going to be to figure out how that complication works out. And we, this one here, this 3x squared over 4 is a little simpler example than these other two, saying the same thing. I have 3 times x squared. We don't know what x is, so I don't know what this numerator is, but we're going to divide it into 4 pieces. Same thing as the pizza example. It's just expressed more difficultly, and we don't know what a lot of the pieces are. So it's not as simple as 1 over 2. We don't know what that x is, and until we know, it's a lot more difficult to solve and to kind of picture. So even when we're using big numbers and fractions, like 1/2 is pretty easy to picture. We can picture 1/2 of something, but 5,003 over 32, that's a fraction. We can still work with it. We can convert it to different things, but at least in my head, I can't picture that. Well, in 1/2 I can picture, but in my head, I can't picture 3x squared over 4 very easily. And I most definitely, in these other 2 examples, cannot picture that in my head. And so we're going from where you learned, like in grammar school, like drawing the pictures of the boxes, to drawing a picture of this stuff isn't really going to help. We're going to have to do the algebra. And you just kind of have to trust that it's going to turn into like a real number or a whole number, something that we can do. So we're going to go back to that idea of evaluation. And evaluation is just replacing the x or replacing the y. So in this case, we're told y equals -2. So remember, and we've done an example of this in a video I sent you. Anywhere I see a y, I'm just going to replace it with -2. And so I have this y minus 2 over -5 plus y. So I have a rational expression. But just like when we had a regular equation, or what we refer to as a linear equation, when it's just an equation out, we do the same thing. There's nothing different here. Wherever I see a y, I replace it with -2. So there's a y here. I replace it with -2. -2 minus 2. And we're not going to do the math right now. Just like we just want to really focus on replacing everything and setting this up. This becomes -5 plus -2. Okay, so that's how it looks. Now, because we got rid of the variable, we got rid of the y, it looks less scary. We can do the arithmetic on it. So -2 minus 2, remember it's a negative. So we're going to keep going to the negative side. It's going to be -4. I hope. And it is. Woo! -5 plus -2. So we're going to keep going bigger. We're adding negatives together. So remember, when we're adding negatives, we're actually getting more negative. So -5 plus -2 is -7. And I've seen you add negatives, and it's great that you know that, because that's one of those concepts that a lot of students have problems with. And since you have a good conception of that, that's really great. That's one of those core things that if you can get how to add and multiply positive and negative numbers, the harder stuff in algebra as we go along is going to be so much easier because you're getting it correct. Okay, so that's just evaluating. If they tell you what the variables are, just plug them in. Just replace whatever letter they have, with the number they say it is, and then do the arithmetic on them. So the only little thing to clean that one up just a little bit more is if you have a negative over a negative, means the whole fraction, the whole rational expression is positive, because really this just means divide. And if we would divide it a negative by a negative, it would be positive. All right, so there's going to be, and we're going to stick with the same example, there's going to be a very important component that you have to remember. And as we try to figure out what x is, and we did that in the homework assignment, we also need to figure out what x or y or whatever the variable is. In this case, it's y. We need to figure out what it is not as well. Okay, and I'm at this point in your math career, the denominator or the bottom number cannot be 0. Okay, so we cannot have 0 on the bottom of the fraction. Now, I do want to let you know that when you go into calculus, and calculus isn't that hard, don't worry about it. The hardest part of calculus is actually the algebra. So the stuff you're learning now is actually the hard part of calculus. When you get to calculus, we divide by 0 all the time. For now, in algebra, unless specifically told by your teacher that you can do this, you cannot have 0 on the bottom. That's just for now, but know that it changes. That's for whatever reason we do that in math. We give you rules and then we completely change them. And that's because every math is different. So later on, this dividing by 0, okay. Right now, absolutely not allowed unless your teacher says so. But for now, we need to figure out, kind of when we were doing the foiling, like what turns something into 0. Well, we have to do the same thing here because this cannot be 0 on the bottom. And if y, remember, if y is 5, if we made y 5, that would make it 0. So y cannot equal 5. So you have to pay attention to that, because if y equaled 5, negative 5 plus 5 equals 0, we have 3 over 0. That's not allowed right now. So we can't do that. So whatever answers we come up with, and this will happen, you'll do all this work that we're going to go through, and you'll get x equals, for example, this is just an example, x equals 3. And because remember, when we're doing the foiling, when we're doing quadratics, we usually have 2 answers. X equals 3 and or y equals 3 and y equals 5. Well, then we have to go back and say, well, no, we already figured out that y can equals 5. So we just throw that away, and then we'd be, well, y equals this other number. So just keep in mind, you do have this, that is part of the step when doing rational equations or expressions. We have to find out what the variable is not. Then we go to solve for what the variable is. And again, remember, if we have a quadratic, that's that. It starts with x squared or y squared, something squared. If we have a quadratic, we're usually going to have 2 answers. However, if we go back and one of those answers is something we said that x or y could not be, we just throw it away because it cannot be that. And when we do have something on the bottom, we do call it undefined. Like I said, later in your math career, completely acceptable. Right now, you cannot. So, and that's just words. So we'll take a look at another example. Now, keep in mind, sometimes it's not going to be as easy as like 5 minus 5. You're going to get an expression here, and that's kind of where that factoring ability comes out, to be able to break these expressions into different forms so that we can cancel things out. The canceling out in a rational expression is what we really want to do, because we want these expressions to be in their simplest form, because they're easier for us to comprehend. Like this one, like I'm probably right on board with you when I'm like, I don't want to do that. Other than the fact that I can see things because I've been doing this for a long, long time. So Also keep that in mind. When you don't recognize a factor, especially one of these algebraic expressions, it's not because you're bad at algebra. It's not because you can't do it. It's because you haven't seen it a lot. So I've seen this a lot of times, and that's the same thing with that foiling method. I can see the numbers because I've done them a lot of times. And so it's easier. So it's like for me, I can see that that's a factor of 3. That's going to be a factor of 3. It's actually going to be a factor of 15. I got my 3 there. That's nothing. So, but I know, so that's what we're trying to do. What number is going to make it 0? Well, remember I mentioned that I could see that that's a factor of 15. Well, that's because 15 plus 15 plus 15, so 3 times 15 is 45. That means if I made this x right here -3, because I would make that -45 plus 45, I can't have that. That would make it 0, and I can't have that be 0. So -3 cannot be an answer. I like it when the slides actually have it that I'm correct. So looking at factors is what we're going to do because it's very important. This is just fancy stuff. That's the official definition. One of the other things in math is we have these really fancy definitions and they look scary. But if you can not be afraid is a really big skill in math. Because if we break this down, it does make sense. So P times R over Q times R equals P over Q. All that's saying in a fancy way is, well, if I have P over R and Q over R, the R's cancel out. And that's what we're looking to do when we're simplifying a rational expression, is what can we factor out? If it factors out, if I have a factor on top and a factor on the bottom, I can cancel them out, which is a lot easier to work with. Remember, it has to be a factor. So factor is another way of saying multiplication, division. If it's a term, and we went over that with polynomials, plus or minus, it's not a factor. So you can't cancel out addition, subtraction. So if it was 1 minus 1, you can't cancel that out. If it was 2 minus 10, you can't cancel out, but 2 times 10. And then if on the bottom you have a 3 times 10, we can get rid of those 10s. Those will cancel out. So it has to be multiplication, division. And that's just that's all that is a fancy way of saying that. So we need to factor. So you need to go back to your factoring skills. And that's why if you ever had the question of like, why do we do this? That's why, because if we get these huge rational expressions, we don't want to do them. And I can tell you from my own experience of huge rational expressions. So we're talking like 30 terms on the top and bottom, but they all match up. So I just cancel them all out. That's a lot easier. So that's why we want to factor, because if I remove the factors from the top and bottom, the numbers are still going to be the same. The answer is going to be the same, but my work to do them is going to be a lot easier. And again, it's a lot of experience of seeing that. Fancy words, don't need to worry about it. And that's just reiterating that it has to be a factor. So x plus 1 on the top and x plus 2 on the bottom, those are 2 terms. They're adding. Cannot simplify that. Now, if it was x plus 1 on the top and x plus 1 on the bottom, that's just 1, because anything over itself is 1. It has to be multiplication or division to be able to factor things out. And I can tell you from my own experience, I made a lot of mistakes on that when I was about your age, many years ago. So let's take a look at an expression. 7x plus 35 over x squared plus 5x. So you take a minute to go, ooh, no, not that. And then you take a minute to just relax. Trust me when I say one of the greatest skills you can have in math is not freaking out. Okay, and that's why we're going over these little mechanic videos, because if you can learn these little mechanic videos, you'll be able to learn how to see something scary and then put it into pieces so that it's not scary looking, because that's really what we're trying to do right now with the rational expressions. How can I make this thing less scary so it's easier to work on? All right, so I'm just looking at it myself. And right now, I know that 7 is a factor of 35 because 7 times 5 is 35. So multiplication, that's a factor. I also see here that this has an x and this has an x. So that means I can factor out an x. So if I take out 7, because remember 7 times x, remember I told you they have to be multiplication. That's multiplication. I'm going to take the 7 out of that. And this is how we do the notation. This is, I'm taking a 7 out of this. So, and we can double check. 7 times x is 7x. So that's legit. If I take that 7 out of 35, well, 7 times 5, I leave the 5 inside the parentheses, and I could double check because 7 times 5 is 35. So 7x plus 35 is the same thing of 7 times the quantity. Remember, that's what we call something with in parentheses, x plus 5. Because if we multiply this out, it would turn back into that. So it's the same thing. 7 times x is 7x. 7 times 5 is 35. All right. So we factored that out. And hopefully that's going to be useful to us. So now we're going to factor this. I know I have an x here and I have an x here. So I'm going to factor out the x. So I'm going to set it up with the x out here, make a parentheses. Well, remember, we went over variables. So it's a factor. If I factoring or variable exponent, if I factor out an exponent, if I multiply or divide an exponent, I'm actually subtracting or adding. So x minus x leaves me with an x. If I multiply them together, x times x equals x to the power of 2. Completely correct, completely legitimate. All right, so like I have an x here, so I'm going to get rid of the x. Remember, if I'm, so we're really adding and subtracting when we're factoring multiplication. So an x minus x is 0. So now I got rid of that. So it's just the 5 by itself. And we could double check. X times x is x squared. X times 5 is 5x. Goes right back to what it is. Now I have these two x plus 5s. I can get rid of those. Those cancel out. So now I'm just left with, ooh, I forgot this had animations in it. Now I'm just left with 7 over x, which is a lot easier to understand and see. And if I told you x is 1, then it's 7 over 1. X is 3, 7 over 3, which is a lot easier than me telling you x is 3 over here. And you're like, 7 times 3 is 21 plus 51. 3 to the power 3 squared is 9 plus that. It's just a lot more work. So now we simplified it so this is easier. And if we go back to the previous example, 0 can't be an answer. So x cannot be 0, and x can be anything else but 0, negative and plus. But we're not exactly solving for that, and we don't have to. But you can kind of see. Now you can just say, well, x is any real number other than 0. So we'll try doing a little simplification again. Again, this one's kind of big. You take your moment to be like, no, take a breath. You can do this. Now, what I see, and I hope you'll start seeing this as well, is these expressions, both of them, start off with x squared. And then they have an x with something in front of them. And then they have a constant. We've gone over, that's quadratic. So that's when you're going to start doing your FOIL method to factor things out. So that's what it actually breaks down to. But foiling is so important. I want to kind of go over it quickly. Remember, you see that, you automatically just write your parentheses, put an X, and then you want to find two numbers, because you're going to need the number here and the number here, that when added together will equal this, but multiplied will equal that. Okay, so in this case, 4 times -1, because 4 times -1 equals -4, but 4 minus 1 equals 3. That's what these numbers are going to be. And we can prove this out. X times x is x squared. X times -1 is -x. 4 times x is 4x minus that -x we had, 3x. 4 times -1 is -4. Foiling is going to take a lot of practice. It's not one of those things you're going to get just off the top of your head. Just requires practice and experience. So same thing down here. This is quadratic. I have a power to 2, a variable, just x, and a constant. Remember, constant is what we just call the plain number with no variable. Again, x times x is x squared. X times 4 is 4x, and we kind of just have that on the side of our paper. -5 times x is -5x. -5 plus 4 is going to give me -x. -5 times 4 is -20. So see how -5 times 4 equals this? But when I add -5 and 4, it gives me this, because -5 plus 4 is -1, which is -x. So now we have them simplified. So now we can take a look, and look, I have an x plus 4 times, super important, and an x minus 5 times x plus 4. I can get rid of those two. So that's going to simplify that. So now I have x minus 1 over x minus 5, which is a lot simpler than dealing with this. And you can see, remember, we need to check for zeros, that 5 minus 5 would be 0. So 5 cannot be an answer. Now we're not going to solve for x, but again, remember, 5 cannot be an answer, which is super important. So we're going to simplify again. This one's a little trickier. So this is going to be a little complicated. So remember, I think at least for me, instinctually, I want to switch them around, be like -7 and y, but it's completely different. Y minus 7 is different than 7 minus y, because we don't know what y is. So we need to resist that. At least I have the urge to do that. You're probably a little better than me. So don't try switching things around without doing the math behind it. And what we can do, though, is we can factor out on top a -1. Okay, so because everything has a -1 in it, and essentially that just changes the signs. So we go from 7 to -7, and from -y to y, which is what we have here. So now we match them up. So sometimes, as a trick, we can factor out the -1 to get things in the order that we want them, or to get the signs to match. Now, keep in mind, we only did it to the top half, and that's fine. We can do that. And now we have that. Those cancel out, and we just have -1. So I do want to take a moment to tell you another trick that we use a lot. And we kind of did a version of it in the homework example. But knowing your creative ways of one, and this comes in very handy. So remember, when we're doing, if this were an equation, we can do anything we want as long as we do it at both sides. And that's something that's going to come in handy, because sometimes we're in a spot where things don't work out easily, but if I multiply it by 1, it's okay. And, just remember that in like 1, oops, I switched. Anything over itself is 1. I can put something over 1 and it's itself. So I'm just trying to go through slides. It's not it's allowed. So you will be able to solve things if you can, just switching over to a whiteboard, if you can learn how to create ones. So remember, anything over itself is 1. So 3 over 3 is 1, right? And the only reason I bring that up is that if I have something where I want to get rid of a 3, I can multiply that by 3 over 3, because those will cancel out. Now, in this case, not the best example, because then it just becomes 1/3 back to where it is. But just, I want you to know that that's a trick you can use. I'll need to look up a better example to use in that case. We also use, and we've done this in the homework, where we can just put something over 1, and that's legit. And so if I was trying to get rid of that 3 on the bottom, those cancel out, and that just becomes 1. So just know, like, if you can come up with ones, it's a very helpful skill to have, because when things get horrible, and let's just say we have like x minus 3, and again, not the best example, but I just want to keep it simple. And I could do x minus 3 over x minus 3, because anything over itself is 1. And this comes in handy when these expressions get bigger, because there might be a time too, depending on what's in the numerator, that'll make it simpler to be able to multiply that x minus 3 on top, or even to multiply that x minus 3 on the bottom. So just know that that's a trick to use, a math trick. I don't have a really good example to go over right now, but remember, anything over itself is 1. I guarantee you're going to come across it. So anything over itself is 1. Anything, any number or variable that you have, you can put over 1, because that's itself. And we did that in the homework example. All right. So I hope this was helpful. That's some of the mechanics of what you're going over now. And it's going to help you on the questions that I'm not helping you with when you're doing it on your own. Knowing that simplification, knowing how to factor, and knowing that certain numbers can't be 0. And that's actually something we're going to go over in the next video I do, of how you just kind of throw away that answer, because you cannot have 0 in the denominator. And that's also kind of a test trick. They'll give you stuff and you'll end up with the 0 in the denominator, and you can't have it. And that's kind of like the trick that a lot of teachers like to give you on the test. All right, that's it for now, and I'll do another video of an example for you.